So, hello everyone. I was trying to get used to the Mac because I'm not used to it. So, yeah, as Floor said, I have a very nerdy joke. So, at the same time I started learning JavaScript, I also started using VI, and ever since I couldn't quit. So, there you go. Thank you. It was a very good joke. So, you're not here for my jokes, you are here because you want to listen what I have to share about the things I learned about writing the fastest JavaScript server in the world. It's a very full-mouth title, so I think it's very cheesy, so it's very interesting to people to come and see. So, to get things started, so I started, when I was preparing to get ideas for the talk, I went on my search engine and I typed the search question, is JavaScript fast? And going through the results, you see like stuff like this, like how fast is Node.js, and you see under the right circumstances, it is very fast, actually faster than C, or as fast as C. I'm like, okay, that's quite interesting. And I kept going. Other results was like, as soon as you understand the event loop and now it processes requests, you realize that why is it so fast? I don't think it really answers my question, but it's quite interesting to read. And I kept going, and I found stuff like, why can it be so fast if it's multi-threaded? And the most popular answer was because it's lightweight. Still, yeah, interesting, but why? I don't get why. So, and then I continue like how fast is compared to Java, and people say, well, JS is awesome and hot and shines when it comes to a huge amount of short connections. Okay. And then I just gave up after this one, where like, what makes it faster than Java? And the answer was because the ecosystem has more than 50,000 modules written in a synchronous style. And as you know, NPM just went over 1 million last week, so this is very, very old search result, but it's on the top list. So, what I want you to tell is like, can we trust the internet? Like I don't know if you guys follow the Game of Thrones, but Tyrion Lannister said on the last episode something like, stories connect people and internet is full of stories. And I'm not a storytelling person. I'm more of a software engineer. So my answer is like, I don't trust the internet. And I'm a software engineer because this fantastic lady, if you guys don't know, it's Margaret Hamilton, who managed to write software to get people landing on the moon safely with just 2 kilobytes of RAM. Imagine what you can do today with 2 kilobytes of RAM. But she also defined the term software engineering. So when we talk about engineering, we're talking about applying mathematics and physics to the way we solve our problems. So in order to go back to the question, is JavaScript fast? We need to be able to reproduce a problem, we must be able to explain and verify the results. So, to me, the right answer is JavaScript fast? I don't know, because all the previous answers didn't really give me a concrete answer. So, I went on a quest, and that's why I decided to start this talk. Like, when I started it, I decided to pick up the title, 10 Things I Learned Making the Fastest JavaScript Server in the world. So I chose the word server very carefully. So a server is just a computer in a network that is used to provide services to other computers in the network. So what I'm about to tell you doesn't apply for command line applications, serverless functions, because they are totally different kind of environments. And then I need to define what fast means. So for example, if I put a Raspberry Pi on a Formula 1 car and send it on a racetrack, of course it will be really, really fast, but that's not what I mean. What I mean by fast is metrics that you can use. So I didn't want to invent my own metrics, so I found out that there is this group of people that they are called site reliability engineers. And they have researched what are the golden signals that they should look when they're looking into their servers. These signals are very important because they allow them to verify what's going on and where on the network and the health of their applications. Funny enough, Google has one of the best teams on SRE in the world, and they just messed up last week or 2 weeks ago. But anyway, they've written very nice books that you can see on that link, if you want to know more. So they defined like 5 golden signals. They are rate, errors, latency, saturation, and utilization. I'm only going to focus on the first 3. So when I consider like rate as in requests per second, errors like in errors per second, and latency as in response time, including the queuing and waiting, what this means is that I'm just focusing on my application. I'm not focusing on the hardware. I'm not focusing on my operating system. So, in order to understand what I'm going to measure, I need also to understand the life cycle of my application. So, what is a server application? So, a server application is first a long-running process. Second, it's deployed on the cloud or in bare metal. It should be attached to a fast network, otherwise network is your bottleneck. It should have enough CPU and memory, so the operating system and your hardware are not the limitation of the performance of your application. So now that I kind of went over the life cycle of the application, we need to talk about how do we measure, how do we benchmark the results. So if you go again on the internet, you'll find lots of articles where people tell you how fast something is. They have nice graphs, but from an engineering perspective, this approach is wrong. The right approach is that they should provide information and the nice graphs, but they also need to tell you how exactly they achieve those results. Because from a software engineering perspective, you should be able to read the results, reproduce the same experiment on a lab environment, and get again the same kind of results. On top of that, it should be peer-reviewed by other people, so they can verify that your results and your questions are correct. So writing benchmarks is really, really hard, and the most important thing about benchmarking is that once you benchmark something, it doesn't really necessarily mean that you are representing a real use case. So usually you only benchmark a small subset of your application, so all results need to be taken with a pinch of salt. So given that it's really hard to write benchmarks, and writing a meaningful benchmark, it's even harder because it needs to be verified by everyone, and it's a really complicated process. Luckily for me, I found out the Tech Empower framework benchmark, and this framework benchmark is quite interesting because it has a couple of interesting features. First, it has more than 500 contributors, so more than 500 people have already contributed fixes and verified the code. Second, it has already received more than 3,000 pull requests, so lots of changes and verifications have been made to the benchmark. And the Git history goes over 10,000 commits. So if you want to know more, the URL on GitHub is there. And the benchmark is interesting in the fact that it already tests more than 630 different frameworks across many different languages. So you can kind of compare everything against everything. So I went on their results page. And because, as I said, there are 630 frameworks being tested, it's quite hard to put everything in a slide that is visible in the end of the room. So I had to skew the slide on purpose. But don't worry that you cannot read it, because this is kind of intentional. And the question I want to ask is, where do you think you'll find the first JavaScript framework? It in the middle. That's what I heard. I'm going to hint you. It's going to be there. The first JavaScript framework on this benchmark shows up at number 89, just to be correct. So this was kind of a shock, and because from the search results, everything should be fast, and everything is fast. So what the heck is going on? So my next step was let's look under the hood, because we need to understand what's going on. The benchmark is composed of many tests, so I'm going to go only through the most basic one to explain the process. So I look at the first test, which is just serving a hello world text, and I removed lots of the craft of the code, and this is what you can see. You create you create an Express application and use the cluster module to fork your application as many CPU cores your application has. So you use all the CPUs, you're not wasting resources, and then you just create your Express application with a get endpoint that returns the hello world. Simple. So after this, I decided let's go profiling. So I just went over the profiling Node.js documentation, and they have this very good tutorial on how to visualize your code with flame graphs. And this is the result. Again, don't worry about not being visible. This is just to show you that if I would zoom in, the interesting part is that probably what you will observe is this. Most of the time, the CPU time that you saw on that flame graph is consumed under the dash line in the native code. In the node bindings, in Chrome V8, in the sync.io, in the event loop, and a very, very tiny bit is spent on your code, in your JavaScript. So basically what the flame graph is telling you is even if I would start yak shaving that code, I would only optimize the tip of the iceberg. So I got into the mode, that's kind of not cool. So I decided to start looking into other JavaScript runtimes. So every time I say JavaScript runtime, probably everyone just thinks V8, because it's the engine under Node.js. But there are more engines out there. For example, if you look at the Kengax table, which shows you the ES compatibility across engines, which is not an official authority on engines, we'll see stuff like Shaker Core, SpiderMonkey, Script Core, and recently GraalJS. So GraalJS, I kind of tried them all, and GraalJS is kind of interesting. So I decided I'll try to look a bit into this. So GraalJS is a recent open source project by Oracle, but has been in development for 9 years already. And it's a research project where basically what they're doing, they are creating an optimizing just-in-time compiler that allows you not to use a specific language as input. So you can use any kind of source, Scala, Java, Groovy, JavaScript, Ruby, R, Python, C, C++, Rust. And then either integrates with other applications by replacing the runtime engines, such as the OpenJDK from Java, Node.js, and even creating native binaries. So I decided to go deeper and learn about this GraalJS. So GraalJS, the goals of the project from the website are to execute the fastest JavaScript code with the best possible performance, full support for the latest ECMAScript specification. Currently, they already support ES 2019, and it has a very fast interoperability with any other languages out there. There are lots of academic papers on it, and this is just a link where they already showed that their performance is on par or better than V8, because the compiler now has full awareness of your application, so it doesn't optimize just your script, it can optimize everything. So knowing that I have a compiler that can do all these tricks, I decided to make an experiment. What if I would create a project that I just call ES4X, as ECMAScript for X? that will do something really unexpected. First, I will remove V8 and use GraalJS. Second, I will remove libuv and use Eclipse Vertex, because libuv is just a native binary that cannot be changed at runtime, and Eclipse Vertex can be optimized by the Graal compiler. So I remove the JIT, of course, and use the Graal compiler. Second, I remove the node bindings and just have type definitions. And the reason is that to write fast code, the fastest code you can write is the code that doesn't run. So type definitions are only used at development time, but then at runtime the engine doesn't need them, so it doesn't need to execute any code. Finally, I will have a very simple CommonJS or ESM module loader, some basic NPM compatibility, but no native modules. And finally, you can use like the default debug and profiling tools like the Chrome DevTools. So I end up with code like this. So the first test that before was just I needed to do a fork. Now I can just use ESM modules and start importing modules from Vertex, which is just a JVM, a Java library. But because of Graal, I can just now mix and match everything and have no performance penalty. I don't need to do a cluster because these libraries will take full advantage of all the cores and also offer me the event loop, so I can have the same programming style as before. So if I put this all together, first I need to install a small binary wrapper that allows me to replace in some scripts the usage of Node and use the GraalJS. So if I do this, now I have here a small video. As you can see, I create a small project, package JSON. I add some dependencies to my NPM. I depend on Vertex core because I need to have it for I/O. I depend on Vertex Web to do the routing of web routes. Now I create a module using ESM module syntax to define what to do when a request is made to the home page. And this request will just return like hello from Vertex with yes for X. And of course, now I need to bootstrap my application, so I create a router. And I do lots of typos as I type, so of course it takes a bit longer. So I have the router. I import my own module, and now I create my app. Pretty much, it starts to resemble a bit like an Express application. So I have an app. Now I say app on route on slash. It will be handled by the module I just created before. Now I create HTTP server, and this HTTP server request should be handled by my app. And now I say listen on port 8080. Can even print it out. Ta-da, application ready. So if I now use like the typical development tools like Yarn to get my packages, and I can do Yarn. I can even debug it from VS Code. And it's interesting here because if I make a request, you'll see that my debugger now shows me all the code that I wrote and even code that it's written in other languages, in this case the Vertex framework, which was written in Java. So the expectation when you use a framework like this is that your user code, your runtime, which is the small library I wrote, they interop with any other languages or libraries that you need. The engine itself, the I/O library, and even all JDK, because in this case I'm running on the JDK, everything will be fully optimized, not just the script like before. So, like almost 9 months ago, when I kind of complete this experiment, I submitted to the Tech Empower, and after being reviewed by them and many other people, it was accepted to be added to the framework. And I got like a moment like Katie Bauman, but she found something really good, but I'm just a developer, so I just wanted to have my own drum rolls, and then I look at the results, and their CI shows that for the first time you'll see a JavaScript framework on the top 10. So in this case, it's a very simple test that on every request goes to a Postgres database, makes a SQL query, returns the result. And if you try to get more concurrency doing many queries on a single request, now we are on the rank number 6. So remember, before we were like on 90, 89, so really low, and now like on the top 10. So how does it compare to all the other frameworks that were already in the benchmark? Because there were a couple of frameworks already out there, and we can now compare everything. So for one of the tests, which is just serializing JSON, which everyone does on a daily basis, the results are something like the previous best result would allow you to do 558,000 requests per second. Now you can do more than 1 million. So it's like more than 2 times improvement. We're not talking about tiny yak shaving improvements. It's like 2-time-fold. Going on a database like before, the best result was 110,000 requests when going to Postgres, and now it's 677. So basically, it's almost 6 times better than before. And I can continue like doing multiple queries, so now you have lots of I/O going on the application. Before, the best result when compared to Postgres was 7,800 requests per second. Now it's 42,900. Or if you want to compare, regardless of the database, it's still 2.5 times better than the best from before. Doing database updates where you need to do lots of concurrency between your requests, you saw the results, right? So the conclusion I want everyone to take home from here is that, in my opinion, there's nothing wrong with JavaScript to writing high-performance applications. Yes, the answer to the Google search is JavaScript can be fast, and we don't need to start switching to Go or Rust or whatever. Well, you can switch if you really want to and if you like the language, but don't use as an excuse that your JavaScript is slow. So dare to experiment, like the previous speaker just said to everyone. And if you want, follow me on Twitter, check the source code, which is the first link, and read the other links about the framework I've used on GraalVM. And thank you.